stock market.
Hello everyone. Very good evening one and all. Welcome to Wallah and warm welcome to the session. Everybody, please confirm, am I visible and audible clearly or not? Everyone, whoever joined live, please confirm my visibility and audibility, dear friends. I am welcoming you all for this first academic session for GATE 2025 aspirants. So all dear friends, am I visible and audible? Sudipto, Benny, Gopi? Yes, great, great. Gopi, let's see. We will try to understand the concepts clearly. Okay, the duration will not be of a fixed duration, but I'll make sure each and every concept that we discuss will be crystal clear for all of you. Benny, yeah, actually it is a good concern for every student, I understand. We are starting arrays concept in the data structures, right? So I'll make sure this arrays concept is completely taught. It is not like we are leaving this concept in the middle. Okay, and once arrays is completed, then if I start another concept, maybe linked list or stack or queue, whatever the concept, whatever the data structure we start, we will complete it. Okay, all right guys, so how are you all doing? How your preparation is going on? Everybody, please confirm your presence as well as please respond in the chat box. How your preparation is going on? I am waiting for your response, dear friends. So today, in this very first lecture of data structures, we are going to discuss the data structure arrays. In that arrays, we will understand insertion and deletion concepts. Benny, of course, yes. So today, what we are going to cover? Firstly, we will try to understand what is an array. Okay, I know when I take out this question, what is an array? Array, sir, we know about it. Array definition is very popular and we are learning since our first year of engineering. Again, you start with the same. Just please be patient, guys. We will definitely try to understand this array from a new dimension. And once we understand what this array is, then we will quickly go through how we declare an array and how we initialize an array. So how to declare an array and how to initialize an array. And then we will understand what is exactly insertion means. About this insertion operation, there are several wrong perceptions for the students. All those will be clear off with this lecture. Same way about deletion. So guys, without any delay, let us start. Okay, can we start, dear friends? Yes, that's great. That is really wonderful. So guys, firstly, to start with, what is a data structure? Because we are talking about data structure. So firstly, we have to understand what is it. Okay, what is there, sir? It is a structure of data. Data structure means structure of data. But what exactly it means? See, whenever I say data structure, it is implying two meanings. It is giving what? Two meanings. What? One is the organization of data. The organization of data. What is this organization means? What does it mean? In the sense, how this organization term is giving what meaning? How we perform operations on data. So how we perform operations. What operations? Usually when you say any data structure, we will be identifying or analyzing few operations like insertion, deletion, before that creation, and then searching, access or traverse, and sorting. So these are what the operations we usually analyze with respect to any data structure. So how you will be able to create such data structure? How do you insert? How do you delete? How do you search? How do you sort? How do you traverse or access? Okay. So this is one meaning. How you organize the data. And what is the other meaning for data structure? It is the representation of data. What is the second meaning that you can adopt for data structure? Representation of data. There are several representations. Like we can represent with Venn diagrams as sets, something like this. We may represent with table, with rows and columns. We may represent with this kind of charts. We may represent as graph. There are several representations for the same data, isn't it? So how you represent? And one point you should be very clear that data structure is not data type. Maybe some students will understand data structure and data type both are same, but actually guys they are not same, they are different. Data type will give you nature, whether it is a whole number or a real number or character or string, what kind it is and how much memory is required and what are the possible values for that. So that is what data type. But a data structure will not tell you how much memory is needed, will not tell you what is the range of values, or will not tell you what values you can give, what values you cannot give. Data structure simply represent the given data in the understandable form. Data structure will give you different ways to access that data. So, are we clear with the definition of data structure, everybody? Are we clear? Sudipto, Benny, Ashwini Kumar, Gopi and all, please respond. Are we clear? Ashwini Kumar, yes. See, we will be doing C implementation, but the concept whatever we are discussing, array, that is useful for DA paper also, because the concept will remain same. Only the program changes. Maybe for DA you may need to implement with Python. In the CS paper you will be implementing with the C language. That is the only difference. But if you understand the concept well, you can easily build the logic. Or you understand the C based implementation, you can easily convert that into Python implementation, isn't it? So definitely it is useful for both CS aspirants and DA aspirants. Yeah. So now, when we understand what is this data structure, what are different categories of data structure? Data structure is classified into, like we can say, data structures classified into two types. Two types. What are they? This classification is pretty popular. What is that? One is linear data structures. The data is represented in the linear form, not in the form of levels. All the data will be represented in the linear form. But in the memory, it is not stored like that. In the memory, it may be stored in different ways. Data structure is just a representation. It is not representing how it is stored in the memory. It is representing the data in our understandable form. Okay. So, linear data structure and non-linear data structure. So, what are the two categories? Linear, non-linear. Under linear category, you can see the data structures arrays, stack, linked list and queue. At least to our syllabus boundaries, we can mention those. Similarly, non-linear data structures are trees and graphs. Till here we have in the syllabus. If we want to consider few more, like you can say sets, maps, also under non-linear category. But we will not be discussing about them due to our syllabus constraint. So, data structures are basically two types, linear, non-linear. From these, let us pick this data structure what? Arrays. Arrays. So what is array? Guys, the definition of an array, what we all learn. There is one popular, common, simple definition for an array. What is that? It is collection of similar data items. Isn't it? Collection of similar data items. That is what we say array. But this array, we can also define something differently. How, sir? We can define array as variable. Array is a variable. Oh, yes. Why not? But what is the difference between a variable and array? Array is a type of variable, undoubtedly. But are they exactly same? No. Why? Suppose if I create one variable x, in the x, if I give value 5, 5 is stored. When I change the value, that is stored. When I change it, that is stored. When I again apply some operation, that is stored. So at any given time, array hold, variable hold a single value. At any given time, variable hold what? Single value. But array is like a variable that holds multiple values, that too similar values, multiple similar type values at a time. At a time. Like if I take array, I can hold 5, 7, 9, 11 for the array at a time. So array hold all the 4 values at a time, but variable hold any one value only at a time. You understood the difference between a simple variable and array variable? Yes? Hello? Everyone, please respond. Right. As in the computers, we start numbering from 0, the default indexing will be from 0. Okay. But there is a facility of random indexing with array also. The default indexing starts from 0 because you see any data structure or in the computers numbering, you say height numbering, level numbering, depth numbering, degree, any numbering will start with 0. And that index cannot be in fraction. It can't be a real number. It cannot have a fractional value. So it should be a whole number. And it should be unsigned integer. So the unsigned number starts with what? 0. Right. So the index data type is unsigned integer. Unsigned means only positive. Integer means whole number. So the range starts from 0. That's why the default indexing will be from 0. But the index can be signed integer also based on our implementation. Okay, fine. So the other definition for array we can give as it is a variable, but it can hold multiple values of similar type at a time. Now one more definition I can say, for array, that is array is a reference. Array is what? A reference for group of similar values. Group of values of same type. Okay, here I can say group or single also fine, because array can have even one value. So let us see what this mean. Everybody focus. Suppose I say int x is equal to 5. This is a variable or array? Everybody please respond. Is this a variable, a simple variable, or array variable? Hello? It's a simple variable. Very good. Now if I print this with its name, what will be printed? What will be printed? 5 is printed, which is value of data, isn't it? Value of data. Now on the other hand, if I create it like this, now what is x? Variable, simple variable or array variable? What is x? Is this a simple variable or array variable? It is array variable. It is array variable. Now if I print in the same way, if I print x, like how I used the name of the variable here, here also I am using the name of the variable. But now what will be printed? What will be printed? Do I get 5 only? No. What will be printed? Address. Some address. Okay, let's say this x got this 5 at address 1000. So now we will get what? 1000. This is what? Reference. This is what? Reference. So a normal variable or a simple variable will always give you value with its name, but array name will give you address, or you say the apt term is reference. So guys, these 3 forms of definition of an array. Is this clear for everybody? These 3 forms of definitions for an array. Please respond. Benny, Yes, I'll try my best, Benny, definitely. But whichever the concept we pick up, I'll definitely make you hero in that concept. Although, that is for sure. Yeah. Now, in this arrays, we know there are two types. One dimensional array and multi-dimensional array. One dimensional array and multi-dimensional array. One die array is also known as vector. Under this multi-dimensional category, multi means more than one. You will have this two-dimensional array, three-dimensional array, four-dimensional array, and so on. And so on. Okay. Now, if I pick 1D array, one-dimensional array, to proceed with this insertion deletion understanding, how I create this array? So, declaration of an array, how I create? I can create it in two ways. In two ways. Not only 1D array, any array, we can create in two ways. How? How? One, with compile time static memory allocation, other with runtime dynamic memory allocation. With compile time static memory allocation, other with runtime dynamic memory allocation. How that is, sir? See, I can create compile time means data type, you will write the name followed by subscript. A pair of square brackets we call as a subscript. As many subscripts you write, that is what you say dimension. As I am writing one pair of square brackets, that means it is one subscript. It is 1D array. So, for this, if we take an example, I can say it as int x. Char yes. Like this. The other way is I can create it as what? Pointer. I can create it as what? Pointer. Because array and pointers are equivalent. They are not same. They have so many similar features and differences also, but we can create it as pointer. For example, I can create it as int star p or char star s. What is the difference? Here, the memory will be allocated at the time of compilation and the memory that is allocated is fixed. Memory can't be extended or can't be contrasted, can't be reduced, can't be increased. Whereas if you create in this way, the memory will be allocated at a runtime while execution, and as you keep adding the elements, the memory can be increased. And at a periodic intervals, if you are not using certain memory, that would be garbage collected. So both are possible ways to create group of similar data. Right? Okay. So now if I pick up this first thing as data type, name of the array, size. Let's say I am picking this compile time memory allocation scheme. For example, I am creating an array like this. That means what? I am grouping 5 elements of similar type. What is the need to group? Why I should group this? What is the advantage I am getting? Why can't I create them as individual data? Like instead I create them as group. Why can't I create as A, B, C, D, E like this? The point is, if you create it as individual variables for A, B, C, D and E, the memory may be allocated at random locations. So this is what? Random memory allocation. So every variable, if you want to access, the fetch time will be counted for every variable. Whereas if you create it as a group for the 5 variables, the same space will be allocated what? Contiguously. So if you create it as a group, means as an array, the memory will be allocated at one place for all the elements of the group. So what? Here access time will be less. Here access time will be more. Because when they are at different locations, like assume they are persons, students of the same class. If I want to make some announcement to all the students, but all are not at one place, then what I have to do to pass this announcement? I have to find each and every student. Then I will pass on the information. Instead, if I group them and make them sit in one class, all are together, then if I can find that classroom, where that classroom, I need not to search for every student, because in the same place, in the same area, all are one after another. So try to understand the difference. So to access each and every variable individually, I may need more time, because fetching requires more time. Whereas if it is as a group, less time. right? So the major advantage of array is contiguous memory allocation. Okay, now we will get easy immediately one doubt. Okay, sir, contiguous memory we understood, but here, sir, there is a comfort of accessing the variables with their names A, B, C, D. So it is very much comfortable. I can access any variable that I want. That means here I can do random access. Any variable I can access with its name. Is that possible in the array, sir? Definitely yes. We can access even if they are as a group. How? Every element is given a unique index, a unique ID. What is that ID? We call as index. So random access is possible even if you group with a unique ID. What is that unique ID? You call as index. And as just I have mentioned, the default indexing starts with 0. The default indexing will be from 0. Right? Okay. Fine, sir. We know all this. Chalo, move on, sir. Okay. When I want to initialize an array, if I wanted to initialize an array, let us explore, let us spend few minutes of time here. With examples, I will make you understand directly. Suppose I am writing int x is equal to 10, 20, 30. Observe, I have skipped mentioning the number of elements. I have skipped mentioning the size of this group. It is valid or not? Definitely valid. So the compiler automatically understands based on the number of values, the size of this array is automatically understood by the compiler. So here the size of the array is considered as, okay, here size of means again you will take it with memory. Here I can say 3 elements. Fine. Suppose I write x of 5 is equal to 10, 20, 30. 10, 20, 30. Now, array size is taken as 3 or 5. Tell me guys, array size is considered as 3 elements or 5 elements? 5 elements. Always if you give the size, if the size is mentioned, that is always the priority. So here size of array is taken as 5. Then I have not given 2 other values. Fine, they are taken as zeros. As I have given some values, the other values are automatically considered as zeros. Okay. Suppose if I take a 2-dimensional array, usually we give number of rows, number of columns, and we will give the size. We will give the values like this. So for representation's sake, we will say there are 3 rows, 2 columns. Row indexing starts with 0, column indexing starts with 0. Values are always assigned row wise. So the values are given like this. Ten, 20, 30 will have the first index only, starting from 0. The other values are filled with zeros, means the assignment will always start from the beginning in 1D array from 0th index, in 2D array from row wise, from row 0. Row wise always assignment happens. Okay. See, look at this. Suppose I give the same array in this way. Is this valid? Now also it will consider the number of columns as 2. How? I have not mentioned the number of columns, but based on the values it will take, because there are 6 values, you mentioned there are 3 rows, automatically it is understood number of columns as 2. Or you may even omit number of rows also. You are mentioning there are 2 columns with 6 total values. Here automatically the number of rows is understood to be 3. So in any way you can initialize. And look at this, guys. Suppose if I am mentioning like this, 10, 20, 30, 40, 50, 60. This is also valid. We are telling the first row, second row, third row values are so and so. So all these are possible initializations. Yeah, then 2 columns are taken. If you give 3 as number of columns, rows are taken as 2. You cannot give in a reverse order. Always you should give in number of rows, number of columns order only. Yeah. Now look at this, guys. Look at this. Suppose I am writing like this. Ten, wait a minute. 10, 20, 30, 40, 50 and 60. Now what is the dimension of an array? Now what is the dimension of an array? Everybody tell me, what is the dimension of an array? There are 6 values totally. So, will it take it as 3 by 2 array? Will it be taking it as 3 by 2 array? Sudeepto, you are correct. It will not consider it as 3 by 2 array, dear friends. It will take it as 6 rows. Two columns. 6 rows, 2 columns. Row 0, row 1, row 2, row 3, row 4, row 5. Column 0, column 1. First value of first row is 0, 10. The other value is taken as 0. Similarly, 20, 0. 30, 0. 40, 0. 50, 0. 60, 0. So, the array is considered as 6 by 2 array but not 3 by 2 array. So, how we are initializing, that is more important. You just can't initialize as how we want. So, we have to be very careful. Okay? Are we clear with this? Are we clear with this? Yep. Now, if we talk about insertion, what is the meaning of insertion? Insertion means to the existing, adding new elements. So, this insertion when we take, we may want to insert at last index, or we may want to insert at any random index. We may want to insert at last index or any random index. Suppose there is an array and where there are two values which are initialized initially with two values. But for how many elements the memory will be allocated? As you have mentioned the size as 10, for 10 elements the memory will be allocated. You have given only two values. Okay. And the other will be by default initially filled with zeros. Now, when I want to index at last index means here last index means at last means you are filling in the order in sequence. When I write here at last means in sequence. That is very simple. If you simply say x of 2 equal to 30, x of 3 is equal to 40, x of 4 is equal to 50. So, it happens. Usually it happens at how much time? Every insertion is taking how much time? It is a simple assignment operation. So, each insertion is taking constant time, isn't it? That means we write it as big O of 1. When you want to insert in sequence, this is okay, but now consider there is an array. X of 10 is equal to 10, 40, 60, 90. Okay. Now I would like to insert at some random index. I would like to insert at random indices. Suppose I would like to insert 20 at index 1. At index 1. This is an array. Initially we are having 10, 40, 60, 90. These are the indices. Now what is happening? I would like to insert 20 at index 1. I don't want to replace 40 with 20. I want these 4 elements still be there. I would like to add here, add add to the existing. I don't want to replace existing 40 with 20. That I don't want. Then what I have to do? Index 1 is already full. So what I should do? First 90 I should shift to index 4. 60 I should shift to index 3. 40 I should shift to index 2. Now I got this 40. Though you replace, still I am maintaining its value. So now you insert 20. Now you insert 20. Right? Okay. Suppose I would like to insert 30 at index 2 now. How I insert? This is the array. With indices 0, 1, 2, 3, 4, so on. And the values I am currently having are 10, 20, 40, 60, 90. I want to insert 30 at index 2. Again, I don't want the existing content to lose. I am not ready to lose anything that is existing. So, what I have to do? 90 I should shift to 5. 60 I should shift to the index 4. 40 I should shift to index 3. Now, insert 30 at index 2. So now I am having all the elements. Now I am having all the elements. Right? Now, finally, with one more example, let us see. I would like to insert 70. I would like to insert what? 70 at index 4. So what I am doing, if this is the array I am having, with the indices 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Currently the array is having 10, 20, 30, 40, 60, 90. What I want at index 4, I would like to insert 70. I am not ready to lose anything that is existing. So what I do, guys? What is at index 4, I should shift to index 5. But index 5 is also occupied. Index 5 is also occupied. So index 5 should be shifted here. Index 4 element should be shifted here. Now though you replace index 4 with new value, the old values still retained. So now you insert 70. Like this, if you see the worst case, I am having the array of 10 elements size. Now, I already have 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay. Now, what is the worst case? I would like to insert 10 at index 0. This I wanted to do. This I wanted to do. Okay. Now what I have to do? Now what I have to do? What is at index 0? I have to shift to 1. What is at 1? Shift to 2. What is at 2? Shift to 3. That means starting from this 8 index till that particular index, I have to shift all the values towards right. So, if this is index I, the right side index would be what? The right side index would be I plus 1. Right. So, in programming, what I have to write? What I have to write? The array is what? X here. X of I plus 1 must be X of I. Right. So, if I say I is equal to 8 till I is equal to 0, it should happen from I8 to I0. So, X of 8 plus 1, 9 should be X of 8. So, now I will get 100 here. Then I will be 7. So, X of 8 should be X of 7. That means 90 comes here. Now, I is equal to 6. So, X of 7 will be X of 6. In this way, when I is 0, So in this way, all are getting shifted towards right. When xi is equal to 0, x of 1 will be x of 0. So 20 got copied here. Now actually this 20 will not be erased, the 20 still be there. Now you should insert 10 at x of 0. So now you got 10. Now you got all the values without losing anything. So what we have done, guys, starting from this last index, okay, last but one index, till the first index, worst case I am talking about, we are shifting all the values. We are shifting all the values. That means how many elements you are accessing to do this? Almost all the array. Almost all the array, isn't it? So what would be the time complexity for doing this? If there are n elements, almost n minus 1 elements I am accessing. N minus 1 is still considered as n asymptotically. So for insertion, in the worst case, what is the time complexity for arrays, guys? Big O of n. Big O of n. Is this point clear? Great. Now, you see the code. I have just given you, explained just that particular logic. Here, I am asking what element I would like to insert. Scanned the element, scanned that value. Let's say here I have given 10. At what position you want to insert? Let's say here I have entered 0. Now, for size -1 till greater than or equal to that location, because here you are doing location minus minus. For 0 it may not work, means it will work because we are writing the condition in that way. If you don't want to do minus minus, this equal to need not to be, because you can implement in any way. A of I plus 1 is equal to A of I. That is what here we talk. Right. So this loop is running in the worst case from 0 to n minus 1. So what is the time complexity here? N. After you shift in the given location, you are keeping the value. Right? And then you are printing the array. So if you are just looking for some valid proper code, just for your sake here I brought it. Okay. Now quickly, in the same way, how we do deletion. Let us understand how you perform deletion. Here deletion means actually in the array, the sad part is, it is just a logical assumption that we are deleting. But actually in the array, values still be there. We just move the indices. But I don't want that. I want really the values to be erased. So suppose I take an array consider an array X is equal to 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now, I would like to delete the worst case. Best case is like I wanted to delete 100, delete last element. Simply deletion, like you can replace it with 0. Simply the last index you can replace with 0. That means the value is erased. Or you are using it what kind of a pointer, you can do free. That is okay. But for this we require just constant type. But what is the worst case? I want to delete the first value, the first element. That means if this is the array, with the values 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, I want to delete this 10. Okay, simply deletion. But this space is not getting utilized. If the space is left at the last, insertion would be easy for me. I can do in constant time, because insertion at the end of the array is a constant time complexity operation. But if I leave the space here, we have seen I have to shift all here towards left, and then that is a complex operation. So what I have to do, if I don't want this space to be wasted, what I have to do? Now I have to shift in reverse. 20 I should bring here, 30 I should bring here, 40 I should bring here, 50. That means what actually we are doing, guys? What actually we are doing? Could you please tell me? If this is index I, if this is index I, this becomes index I plus 1. So in X of I am actually copying what? I plus 1. Starting from 0 till the last but one element, I am till the last element I am doing it. From 0 to 9 I am doing it. So here also I am traversing all the array, isn't it? All the array elements are traversed. So what would be the time complexity, guys? What would be the time complexity? Big O of n. Big O of n. So for array insertion and deletion, maybe the best case complexity is constant time, but the worst case complexity will be what? Linear time. Linear time. Got it? So even for this also, you can see the code like a of j equal to j plus 1. Because this is to delete at any index, not at 0th index. I have directly taken the worst case as 0, but I may wanted to delete the middle element also. Then all the right elements should be shifted to the left. So for that purpose, here we are taking that you want to delete value n. So if that is at index I, starting from that index till last, shift all the elements towards left. For that purpose, here we have taken it. So this will be in the worst case, a of I will be 0 only in the worst case. Then this loop run for n times. So the time complexity would be big O of n only. Okay, here it is some val you take. Some val you take. Don't confuse between n, this n and that n. Okay, if you consider it as val, if there are n elements, it would be again n, right? So compared with linked lists, arrays insertion and deletion is difficult. In the linked list, in some cases we take linear time and some cases we take constant time if you take linked list. But in the arrays, this shifting is what the tedious task. Shifting right or left. Shifting right while insertion, shifting left while deletion. That's why there is a statement, insertion and deletion into arrays is complex than insertion and deletion into linked lists. Hope you understood why it is. Yes or no, everybody?